When we look at altitude in a triangle, the altitude is a segment joining the vertex to the opposite side. Now this is not like a perpendicular bisector where it's necessarily at the midpoint. It just means that we have a line coming down from the vertex to the side that is perpendicular. There's nothing about midpoint, there's no angles that are bisected, we've just drawn that line. Now normally we think of the altitude as just like the height of the triangle. When you would have first been finding the area of a triangle, you would do the base times the height, and that's what the altitude is. Now it's not always appears like this, because if I have an obtuse triangle, the altitude is the vertical distance down here, so it may be outside of the triangle, or if it's a right triangle, it may actually be the side of the triangle that we're looking at, but it's that perpendicular going down. Now as with the other ones, we have a point of concurrency when the altitudes all intersect in a triangle. So I have my three altitudes. They all meet at this common point, P, and P is what we call the orthocenter of the triangle. So that is where the three altitudes meet. Now again, there's not much in terms of midpoint or congruence or anything bisected, so there's nothing really special properties we get from this. We just need to understand how to identify that it is the orthocenter. So what really that comes into play is we now have our four types of points of concurrency. We have to be able to identify the name of the segments and the point of concurrency they represent. So let's kind of work backwards from the one we just did. So if I look, only two of these have perpendicular sides in them. The one that is going to be the altitude is the one that's not necessarily at the midpoint but goes to the vertex. So that's our last one here. That's the altitudes. And like we just talked about, those meet at the orthocenter. The other one that has to do with perpendicular is actually, the markings here, is our perpendicular bisectors. So perpendicular bisectors will have the right angles like the altitudes are, but they're going to be at the middle of the side, and they don't necessarily go through the vertex, whereas the altitudes, they will have to go through the vertex. Perpendicular bisectors meet in the circumcenter as their point of concurrency, and remember those are equidistant from the vertices, or the angles, where the angles would be in the triangle. That's the equidistant that we get from circumcenter. The next one, moving left to right here, is we have from midpoints to the vertex, that's going to be the medians. So really the altitudes and the medians, if you combined them, they would give you the perpendicular bisectors, because the medians uses the midpoint, the altitudes use the right angle. Together they're the perpendicular bisector. But if you only have one part, we get those. The medians meet at the centroid of the triangle. Last one is not derived from the sides, but it comes from the angles, and we are bisecting the angles. If we look, this is the only one that uses the actual angles of the triangle, and those are the angle bisectors. And they are going to intersect at the incenter. Now the incenter, as we talked about in that section, is equidistant from the sides. So we could inscribe a circle in that triangle. Now there's not a lot left to do with altitude, so what we're now going to do is kind of go through with the different values that we had, or the different points that we have, and kind of graph on a triangle and find the values that we need. So we're going to start with the circumcenter, and as we looked at, circumcenter is the perpendicular bisector. So for the perpendicular bisectors, I'm going to label here A, B, and C. We first need to find the midpoint of the sides. And if I look at that triangle, the easiest midpoint to find is going to be the midpoint of BC. Because BC, which is a coordinate, let's label those, we have 4, -6, and 4, 8. It's a vertical line. So to find its midpoint, we could do 4 plus 4 over 2, and 8 plus -6 over 2, and that gives us 8 over 2 and 2 over 2, or the coordinate for 1, which if we look is the middle of the two. We really could have just counted up from there. So that's our midpoint. Now we need the perpendicular line from that, and since that's a vertical line, we can draw the horizontal line through that. So there's our first perpendicular bisector. The next one, let's find the midpoint of AB. So A is at -6, 4. So the midpoints, we're going to go -6 plus 4 over 2, those are x values, and 4 plus 8 over 2 is our y values. We get -2 over 2, and be 12 over 2. So we get -1, 6 as our coordinate. And if we look on the graph, -1, 6 is actually where they meet. Now we need to do the perpendicular from that. So it's not as easy as this last one. So let's think about the slope of AB. AB has a slope, it's change in y over its change in x. It goes up 4 units and over 10 units. So up 4 over 10, it has a slope of 2/5. The slope of its perpendicular is going to be its opposite reciprocal, so that's -5, 2. So we flip the value and we change its sign. So to find its perpendicular, we're just going to take that slope and graph from it. So we're going to go down 5 and over 2 to get our point. And in doing so, it actually intersects the first perpendicular bisector, and we get this coordinate of 1, 1. And that's actually going to be our answer for the circumcenter. That's where the 2 points intersect. If I did the third line off AC, it would go through the same point, but we can get by with a minimum of 2 points. Now as we find the centroid, we are first going to go through and look at the midpoints we have of the points. So from A to C, so that's the midpoint of AC, our midpoint formula would be -5 plus 4 over 2 and 4 plus -6 over 2. So it's the average of the x's, average of the y's. We get, that'd be a -1 over 2, and then a -2 over 2, which turns out to be -1/2 and -1, which would be this point right here. Now for, let's say, the midpoint of AB, we're going to go -5 plus 4 over 2, and then 4 plus 8 over 2, which again gives us -1/2 for the x value. And the y value, we're going to have a 12 over 2, which turns out to be -1/2, 6, which would be right there. The last one, the midpoint of BC, we don't really need to use midpoint formula because it goes from 4, 8 to 4, -6. So really can look at the change in y. 4 and -6 are 14 apart. So we go half of that, which is 7, or -6 plus 8 is 2. Half of that is 1. It goes to right there. So there's our other midpoint, and that is at the coordinate 4, 1. Now for the centroid goes from the midpoint to the opposite vertex. So we connect those, and really, again, we only need 2 of them. But we'll draw all 3 here. We connect those, and we see it's at the coordinate. It's going to be 1, 2. Now, the other thing we can do whenever we're looking for the centroid, and this works in this case, is add up all the x values, divide by 3, add up all the y values, divide by 3. So the centroid is actually the average of the coordinates. So if I go -5 plus 4 plus 4 divided by 3, so -5, 4, and 4, and then 4 plus 8 plus -6 divided by 3, we have 4 is 8, minus 5 is 3, so that's 3 over 3. And 4 plus 8 is 12, minus 6 is 6 over 3. So this turns out to be 1, 2, which is our point for the centroid. So that average of all the coordinates does work for it. The last one we're looking at is the orthocenter. So this one is the same coordinates we had up for the first one. So that's A is negative 6, 4. We'll say C was 4, negative 6, and B was 4, 8. Slightly different than the centroid coordinates, but matches the circumcenter. So for the orthocenter is a perpendicular line that goes through the vertex of through the opposite vertex. So let's start with the easiest one. So from B to C, B to C is a vertical line, so its altitude is going to be a perpendicular line to BC that goes through A. So that's actually going to be the horizontal line right here. So there's our first altitude, and we have our right angle. So for the next one, let's look at between these 2 points. So from A to C, I go down, looks like I go down 10 units, and I go over 10 units. So that is actually going to have a slope of negative 10 over 10, or negative 1. So the slope from A to C, we're saying it's negative 1. Now if I'm going to have a line that's perpendicular to it, I need to find its slope to that. And the perpendicular to AC is going to be its opposite reciprocal, which is going to be 1. So with a slope of 1, this is going to give us a line that starts at B and goes down 1 over 1 and then intersects side AC. So this would represent our altitude off of AC through B. Now from that, these 2 points, I get this, or 2 lines, I get this intersection, which is going to be our orthocenter, which is the coordinates 0, 4. I could even come back here and draw up through C and the orthocenter that I have, and it would give me the third altitude. The slope for this one, because it goes up 2 over 5, it would go down 5, 2 to the right, which would also work as an altitude. But really we can use the 2 easier ones to find the point that we need.